Alright, hello, welcome back. Today we're going to look at quadratic formula again. And I know we've done this once in the past, but now that we've covered complex numbers, these show up in these quadratic formulas. So a refresher here, there is your quadratic formula. Hopefully you guys understood that okay back in that second set of problems that we worked on back in that chapter 2. So we're going to use that same formula and solve these types of problems and just kind of refresh our memory on how this works. So remember, when you go through and you work through these problems, you want one side to equal 0. Then you plug it through. So you've got negative b. So negative b would be that negative 6, and it turns opposite. Plus and minus the square root of b squared. So negative 6 squared is 36. Minus 4 times a is 1, times c is 10. So 4 times 1 is 4. 4 times 10 is negative 40 because of that minus there. And all over that is 2a. A is 1, so it becomes over 2. So now working out and solving this, you've got 6 plus and minus. Underneath the radical sign, you've got 36 minus 40. That's your negative 4. And then you got a 2 here. Now this is why this section is a little bit different. We've now got a negative underneath our square root. And remember, negatives underneath the square roots give you imaginary numbers. So with this one, we've got to take that imaginary number out. So it becomes 6 plus and minus. The square root of negative 4 is 2i. And then that 2 is in the denominator. Now since all three of these have a common factor, we can take that common factor out, and it becomes 3 plus and minus I, and there's your final answer. Okay, so when you have an imaginary number in there, you treat it just like you would a normal radical, but then you have to simplify it down. Okay, for example B, same basic idea. We've got x squared minus 4x. Move your 13 to the other side. That becomes a plus 13 equals 0. Then you go through the formula. So negative b gives you 4 plus or minus. B squared is 16 minus 4 times a, which is 1, times c, which is 13. So 4 times 13 is 52. All of that is over 2 times a, which is 2. Now solving inside this radical, you've got a negative, or 16 minus 52, that works out to be a negative 36 over the 2. Continuing on here, the square root of negative 36, well, the negative gives us an I. The square root of 36 is 6, so that becomes 6i over 2. And then all three of these have a common factor, and that'll give you 2 plus and minus 3i over 1, since they all have a common factor of 2, and so there's your final answer. Okay, so quadratic formula follows the same form as the other time you saw it. It's just now some of these may be imaginary, so we work through them that way. Alright, pause the video, give yourself a second to work through this one, and I'll come back and work through it. Okay, if you guys had time to work through this, that's great. So if we set one side equal to 0, we're going to add the 17 to both sides, and that gives you a plus 15 here equals 0. Now there's two ways to look at this. If you notice, all of these numbers, the 12, the 9, the 15, have a common factor, and that common factor is 3. So if we divide everything by 3 on both sides, you end up with the problem 4x squared plus 3x plus 5 equals 0. Now the reason this is nice is because these numbers are a little bit smaller, they're easier to work with. So if you can pull out a common factor, do so. And now you plug it through your formula. So negative b plus or minus the square root of b squared, which is 9, minus 4 times a times c. So 4 times 4 gives you 16. 16 times 5 gives you 80. So So you've got a negative 80 there, all over 2 times a. A is 4, so that gives you 8. Now moving on to simplification, you've got a negative 3, plus or minus. Now in this radical, you got 9 minus 81, which is the square root of a negative 71, all over 8. Okay, so you look at square root of 71, we know that the negative is going to bring out an I value. Then you just ask yourself, is there a perfect square that goes into 71? Well, 4 doesn't, 9 doesn't, 16 doesn't, 25, and nothing's going to work. So what we're going to end up doing is we're going to leave it as the square root of 71 over 8. And now if you look at all of your terms, none of those have a common factor, and so that right there would be your final answer. Okay, so that's dealing with the quadratic formula in cases where you may see an imaginary. Give that a try. If you need some help, contact me online. Otherwise, good luck.